Hello, so today we're going to be talking about exercise 4F, which are polynomials of high degree. So you know that in the previous exercise we spoke about cubic functions and basically this idea that they have this general shape when you put it in intercept form, and as well as that you can draw what's called a sign diagram, and that'll help you kind of determine the shape of it. So when we talk about polynomials of high degree, we start to have this same key idea of how we're able to graph these things. And the best way to do this is by using factorizing, okay? So it's key that you know that factorizing usually gives the bigger picture, and I'm just going to draw a couple of examples underneath of what I mean by that. So, for example, if you've got something of the form y equals a, x minus b, x minus c, x minus d, x minus e. So we're talking about polynomials of order 4, quartic functions. So it'll have, or it could have at most 4 linear factors. If you've got something in this form, this is always a nice thing to graph. So the reason it's a nice thing to graph is because, let's just say, for argument's sake, that you have that a is less than, oh sorry, not a. You have b is less than c is less than d is less than e. Okay, so that means that you know that this smallest intercept is b, then C, then D, then E. Okay. So why is this useful? Because we know the shape of quartic, so it's a positive quartic. So I just want to make one more point that's clear over here. If it's a positive quartic, it has like this W shape, okay? And it has these 3 different turning points. And if it's a negative quartic, then it kind of looks more like an M. Okay, so when we've got something like this, it'll have that W shape specifically with those 4 intercepts. Okay, so it'll look something like this, okay? So that's an example of what your quartic would look like. And then you got to consider kind of what we talked about in year 11 as well, which is like if you have factors that are not linear, what does it start to look like? So for example, if you have something of the form a times x minus b squared times x minus c squared, well, that looks a bit different because now you have your x-intercepts at x equals b and x equals c. However, because they're squared, so remember when you have squared factors, they kind of locally at that point look like quadratic. So what do I mean by that? For example, if I sketch my graph, say that again like b is less than c. So say we put b here and say we put c here, just for argument's sake. So what will this graph look like? Well, because it's x minus b squared, it'll locally look like a quadratic at x equals b and also at x equals c, okay? Can you see that? So this is a couple of examples of ways to understand how quartic functions look like, and we'll do a couple of problems as well. So for question 1, we've got sketch a sign diagram for each of the following. So this is just 4 factors, but you got to be a little bit careful here. And where I say you have to be careful is this 2 minus x. So what I'm going to do is I'm going to write it instead with a negative out the front. And instead of writing 2 minus x, I'm going to write x minus 2, x minus 5. They're the same thing, but now I've got it in a more standard form. I can see the negative at the front, which means that we're flipping it upside down. We're going to have that M shape, and we can see that the x-intercepts are wherever any of these factors equals 0. So we get our x-intercepts at -4, -1, +2, +5. So there, for example. All right, and we know that, as I said before, it's going to be the M shape. So you kind of sketch it the best you can. And you just label your axis intercept. So -4, -1, +2, +5. All right. Don't forget to label your axes, x and y. And then what if you get something like this? This one's a little bit trickier, but there's a little trick you can use here. So if you basically like let u equal x squared, then you can turn the problem into a quadratic because you end up getting u squared minus 3u minus 4, which is the same as u minus 4, u plus 1. Okay, but remember, it's not u, it's x squared. So we're going to turn it back into x squared minus 4, x squared Let me fix that. X squared plus 1. And then once we've done that, we can use the difference of squares to turn x squared minus 4 into x plus 2, x minus 2, x squared plus 1. So just a couple of key things to identify here. You've only got two axis-intercepts, which is at plus 2 and minus 2, okay? And then the other factor, there's no solution to x squared plus 1 equals 0 because you can't get the square root of a negative number. So what does that mean? That means you've only got the two axis-intercepts. It also means you've got the W shape because it's positive. So what must that look like? Well, I might actually shift that up a little bit, 1 second. All right, so if we have an axis-intercept at -2 and another axis-intercept at +2, then what are our possible shapes? What can it look like? Well, we've got to be careful, right? It can't look like this. This is kind of similar to what the other one looked like, but it can't look like this. And the reason why it can't look like that is because the factors x plus 2 and x minus 2 are not squared factors. So locally, like close to the point x equals 2, x equals minus 2, it's not meant to look quadratic. They're linear factors, which means it's just meant to cross through. So the only other way that you can get two axis intercepts with it crossing through rather than just touching and going back up is like this. So if I get rid of that, like this. Okay, it's the only way that it works. All right, and then always when you have something like this, you have the y-intercept. So normally you set x equals 0, but because you can see in the general cubic form, your y-intercept is always just going to be a constant term. So that point over there is 0 minus 4, and your graph is going to look like this. All right, so moving on to question 2, we've got a function, x to the 4 minus 6x squared plus 9. We want to use the coordinates of the points where that graph intersects the x and y axes, okay? We want to use that to sketch the graph. So, little typo, that's meant to say f of x, not p of x, all right? So, if we go to sketch this thing, we got f of x is equal to x to the 4 minus 6x squared plus 9, and we can use the same trick we used before. So you let u equal x squared, you get that f of u equals u squared minus 6u plus 9, which is the same as u minus 3 squared. But remember, that is x squared. So then we can say that f of x is equal to x squared minus 3 squared. All right, so x squared minus 3, we can again use the difference of squares to write it as x plus root 3, x minus root 3, but remember that whole thing is squared. So what do we end up getting? We end up getting x plus root 3 as a squared factor and x minus root 3 as a squared factor. Now, why is that useful? Because if we want to find the y-intercepts, you just set x equals 0. Well, you end up getting that f of x is equal to root 3 squared multiplied by minus root 3 squared, which is no surprise, it's equal to 9, and a consistency check we can do to show that that's true is the fact that you got that plus 9 hanging outside the end of the function. And then the other axis-intercept, which is the x-intercept, you set y equals 0. You end up getting 0 equals x plus root 3 squared times x minus root 3 squared. And just because we have an understanding of intercept form and what these factors mean, and specifically what the square does to it and what the cube does to it, then we know that your solution to this thing would be x equals plus or minus root 3. And more specifically, we also know that they are both going to look like quadratics locally because they are squared factors. So what do I mean by all this? This is not a hard thing to draw. So if you just put your y up here, your x over here, you know that it is touching but not crossing at plus or minus root 3. So you just plot your 2 points. And you also know that the y-intercept is equal to 9. So you might plot your 9 up there. And you're just kind of, you're just kind of following the graph based on the x and y intercepts. So it kind of looks like that. All right. And then you just label all your points. So this is minus root 3, 0. This is positive root 3, 0. And this is 0, 9. Okay, so the key idea of graphing higher order functions is you'll typically be given something that can either be factorized using long division, for example, but less likely with things that are larger than a cubic, or you'll be given something where you can do some nice pattern spotting and you can write it in factorized form and plot it quite easily, okay? So I've just noticed that I haven't actually sketched a sign diagram, so I'm not doing what question one's asking me to do. So I'm just going to sketch a sign diagram as well as the function. So remember, when it's, oh, 1 second. When it's crossing through, when it has an x-axis, sorry, an x-intercept, we draw vertical lines like that, like we spoke about in class. When it's negative, we draw our sign diagram on the negative half. And when it's positive, we draw our sign diagram on the positive half. So it's just positive, negative, positive, negative. And then finishes negative, okay? So this is the positive values, this is the negative values, all right? And similarly for this one, well, it starts, well, it's 0 here, and it's 0 here, right? It's positive all of this region. It's positive all of this region. And then it's negative all of this region, okay? So we can use sign diagrams to help us find what the function looks like, or similarly, if we know what the function looks like, we can kind of draw a sign diagram as well. One other thing about a sign diagram and why it might be useful to help you visualize the function is, let's say, for example, we didn't know anything about what the factorized form looks like. What we can do is we can just plug in an x value. So for example, let's say we wanted to know at x equals 3, is this graph positive or negative? We know it's positive because we know the shape, but let's say we didn't know that. If x equals 3, so let's just say x equals 3 is what we're considering. First factor is, so you got a minus out the front, and then you got a first factor, which is 3 plus 4, positive, x plus 1, so 3 plus 1, positive, 3 minus 2 is 1, so positive, and 3 minus 5 is negative. So can you see how we get 2 negatives and 3 positives? You know if you multiply 2 negatives together, you get a positive. So the overall outcome is positive. So you know that whatever x values make the factors equal to 0 are always going to just cross through like this. Yeah, these are always going to cross through. And we can figure out, based on the pattern of what a quartic looks like or higher order functions, whether it's going to be positive or negative between the regions just by subbing in one value between the regions. So that's another useful way to learn how to sketch a sign diagram. Okay, so I think I've said everything I want to say. So you guys are going to go ahead now and work on questions 2, 3, 4, 5, and 6 for this exercise. So exercise 4F, questions 2, 3, 4, 5, and 6. Thank you.